Let x be a random variable with this PDF. Sample size of 3 is randomly selected. Let y be a random variable representing the median value from the sample. Calculate the variance of y. So here we will use this order statistics formula that if x1 through xn are independent and identically distributed random variables, and x subscript 1 and so on are these variables in ascending order. Now when we just said x1, x2, x3, the values could be mixed up. But now if we write them in the order starting from the smallest to the largest, then the CDF of the rth ordered variable equals this summation. And in this case, n is 3. N is the total number of variables. Here we are given a sample of 3 variables in the problem, so n would be 3. And R is the one which we are looking for, is the position which we are looking for. So in 3 variables, so just imagine we have just these 3, x1, x2, and x3. And we were asked for the median, which means we are looking for the middle one. So in reality, we're looking over here. We're looking in the ordered ones because to find the median, you first have to order the list. So if I want the median of these 3, for example, we know that it's going to be the second one. And that's why R is 2. So R is the position of the variable in which we are interested. And now we first, in this formula, we need the CDF of the main function, which is this one, fx of y. So we know that CDF is just the accumulation from -infinity up to that point. So the CDF at y will be the integral from -infinity to y of the PDF. And the PDF of x is given to be 2x. So if we go back to the problem, so you see PDF is of x is 2x when x is between 0 and 1. So the CDF would be 0 to y. Y could be any value between 0 and 1. And so the integral of 2x is x squared. And when you substitute the limit, it's y squared minus 0. So we get y squared. And we now substitute this value of this CDF in this summation. So as we already know, n is 3, r is 2. So this summation, we replace n with 3. So it becomes 3 combination j. And j was going from r to n. So it will go from 2 to 3 in this case. And here we need the CDF in the formula. So CDF is raised to the power j. So our CDF was y squared. So we'll have y squared power j. And then we have 1 minus the CDF power n minus j. So 1 minus y squared power 3 minus j, because our n is 3. And now we open up this summation. J is 2, the lowest value. So 3 combination 2. And when j is 2 here, 2 times 2 would be 4. So y4. And then 1 minus y squared. 3 minus 2 is 1. So you just have 1 minus y squared. And then when j is 3 in the second summation index, so 3 combination 3, y power, and now when j is 3 here, 3 times 2 is 6, so y power 6, and 1 minus y squared power 3 minus 3, that's just 0, so 1 minus y squared power 0 is just 1, 3 combination 3 is 1, you just get y6 from the second term, and then from the first term, 3 combination 2 is 3, y4, and then 1 minus y squared power 1. And this simplifies to 3y4 minus 2y6. And this is the CDF of the second ordered variable. And the PDF of it would just be the derivative of the CDF. So you take the derivative of this one. So that's 12y cubed minus 12 by 5, and y will be between 0 and 1 as given in the problem. And so EY is the expected value of y. The question, if we recall, was asking us the variance of y, and for the variance of y, we need ey and ey square. And once we have the PDF, we can find both ey and ey square. We know that ey is just the integral of y against the PDF. So y times gy would be 12y4 minus 12y6, and we need the integral of that. And that will come out to be 24 over 35 once you integrate this and substitute the limits. And similarly, ey square will be the integral of y square against the PDF y. And so when I multiply the gy with y square, I get 12y5 minus 12y7. And now I integrate this and substitute the limit. I end up with 0.5. Don't forget to integrate these first. It's a very common mistake in these kind of problems that you see this expression and you just think that the integral is so easy that you forget to integrate it and you just try to substitute the limits in this expression, but you first have to integrate it and then substitute the limits. And then variance would just be e of y squared minus ey whole square, so 0.5 minus 24 over 35 whole square. That comes out to be 0.03. That's choice B.